Okay, a very good morning to all joining us in this webinar. So sorry for the technical delay in allowing the participant to join us, but anyway, we will continue with the session. And before we proceed with the webinar, I would like to request the rector of our college, Father Joby Joseph, to bless us with a prayer.
Thank you, Dr. Sridhar. Dear participants, resource persons, as we come together for this webinar from the Department of Chemistry on natural products, their importance and applications, let's turn ourselves to the Lord. We place ourselves, surrender this day and everything before the Lord, for the Son and the Holy Spirit. God our Father, we thank you for this opportunity. We listen to a reading from the Holy Bible. It's the Lord who gives us everything, who grants, sustains, and guides. From the book of the Holy Bible, Psalm number 8. O Lord, how sovereign, how majestic is your name. When I look at the heavens, the work of all your hands, the moons, the stars that you have arranged, what are human beings that you are mindful of them, mortals that you care for us. But yet you have made us little less than God and crowned us with the glory and honor. What sheep, oxen, beasts of the field, birds of the air, and the fish of the sea, whatever passes along the paths of the seas. O Lord, how sovereign, how majestic is your name through all the earth. But our Father, we thank you for all your gifts to us. May we honor and all that you give us in creation in the universe. May they be instruments to us to glorify you and to our own merit. We surrender this day, the resource persons, and all the participants into your sacred hands. Bless us, and may we grow in knowledge of you and to glorify you. In your precious name, Lord, we pray.
Okay, thank you, Father, for the blessing through a prayer. And Falando, please check one of the resource person is having some problem with joining Sir JC Bora. Sir, are you here? I think Sir is there.
Sir needs to join with audio.
Okay. Sir, please join with audio. Hello, sir. Sir Bora, I think you are okay.
Good morning.
Good morning, sir. We can
Sorry,
see
everyone. So, yeah.
It's okay. It's okay. So we have started with a prayer. Now I will call our head of the department, Dr. I.C. Dalin Snaitang, to give a welcome address.
Okay.
Am I audible?
Yeah.
Yes.
Yeah,
all right. So a very good morning to all of you here. So first of all, I would like to welcome our rector, Father Joby Joseph. Thank you, Father, for sparing your time to be here with us this morning, and your presence here. It brings a warm atmosphere to our program. So very thank you to you, Father. I would also like to welcome our resource person, Dr. Jagat C. Bora, Associate Professor, IASST Guwahati, Assam, and Dr. G.S.M. Mungshel, Scientist, Natural Products and Medicinal Chemistry, CSIR, IITM Jammu. I would like to welcome both of you, sirs. We know that you are very busy, but still you accept our invitation to be the resource person in this program. So, and we will benefit from your knowledge while listening to your lecture. So I would like to welcome both of you, sir, to our program. And also on behalf of the Department of Chemistry, I would like to welcome all the participants here, the teachers from other colleges and from our college also, as well as the students from our college, from other colleges or university or the research scholar. All of you are here with us. We would like to welcome. We extend our warm welcome to you, and your presence here will really grace the atmosphere. So with these few words, I would like to welcome everyone and thank you.
Thank you, Dr. IC, for a welcoming address to all of us. So now we have a participant joining. So 100 participants for now, so we can continue with the session 1. So I'll just give a little bit introduction to our resource person in the session 1, Dr. Jagat Sibora. I'm very thankful he agreed in the last moment. So much work everyone is having, but anyway, I hoped we will get a very good information and knowledge from sir. So Dr. Jagat Sibora is at present is working as an associate professor at the Institute of Advanced Study in Science and Technology, IASST, Guwahati, Assam. And his research field of interest is on traditional and modern drug discovery and disease diagnosis. And we are very fortunate to have amid us a very experienced scientist and professor from the field of natural medicinal chemistry. Since Sir has been associated with many institutes, as I have seen, he has been a postdoctoral research associate from New York, then a senior research scientist at Guwahati Biotech Park Incubation Center, as a principal scientist at Phyto Biotech Kolkata, and also from CSIR and EIST, Assam, and also as a scientist at Institute of Bioresearch and Sustainable Development, IBSD, Imphal. So Sir have had a lot of experience as a scientist, and we hope we will get more information about the natural products from Sir. And presently, Sir have 5 scholars working with him. So one have already completed a degree, and with 29 publications in various journals of synthetic and medicinal chemistry and related journals, along with 5 patents. So I'm giving you all a short introduction, with Sir, because we need to hear more from him and acquire more knowledge from him. So I hand over to Sir J.C. Bora to deliver us the importance and application of natural products. So, Sir, you can take your time now.
Am I audible?
Yes, sir.
Okay. Thank you, madam, for this giving me this opportunity to interact with you all. Honorable Father Jobji Joseph, sir, then Honorable Head of the Department of Chemistry, then Madam Diame from the Department of Chemistry, Dr. J.S. Momo. For a long time I know him, so he's my colleague and good friend. So, and all participants. So a very good morning to all of you. So now I'm going to share my slide. Can you see my slide?
Yes, sir.
Yes, sir.
Whether it is full screen now?
Yes, yes.
So it's moving?
Yes, sir.
Okay. So today's discussion is mainly the nasal products and their importance and applications. So I will start my topic like a common sense, then science and nasal product in the drug discovery. So we know the use of nasal products. So when we born from the mother's milk to end of our life, actually we are primarily depends on the nasal product. It may be plant product, it may be animal product, so it may be any form of the other products. But this scientifically validated product was not developed in a day. So at the very beginning, initially, it was based on some common sense, then some belief of the people, some traditional knowledge, then scientific interventions entered into this. Then finally, we have now some modern products, including modern drugs. So this common sense, does experience-based decision or traditional use sometimes depends on the prejudices So the information is sometimes correct and sometimes may not be the correct. So that is why we need some scientific intervention to establish this natural product for a global acceptance. Now, if we go long back to the Bible, so this Adam and Eve story, if we ask a question now, does this Adam and Eve's original sin have to do with an apple? So, or we know that an apple keeps the doctor, they keep the doctor away. So does an apple really keep the doctor away? So this is the question. These are the beliefs. So now if we go back to the Ramayana, so if we see that when Lakshman was dead, so Hanuman was sent to bring this Sanjeevani so that he may be given the re-life. But as Hanuman did not recognize the plant, so he brought the entire mountain. So as he was not a botanist or he was not a taxonomist. So now if we see, if we go long back, the death of Socrates by hemlock tree. So at that time, there was no scientific validation, but people knew that from their experiences that this tree is poison. If we administer to someone, the people will die. And Socrates' death was given by this hemlock. But later it was established scientifically that because of the presence of this quinine, so this is the toxic molecule present in this plant. This is the scientific intervention. So now, I think, Madam Diabai, a lot of this graduate students are today participants, right?
Yes, sir.
Okay.
Yes.
So now we have a molecule. It is based on actually traditional used in India. This molecule is called bliss molecule. If we, with this molecule, someone may be happy. So what is this molecule? Now, if we see the very historical perspective, when Samudra Manthan was there, so there was some amrit and as well as some poison, which was recorded as a halahal. And it was recorded that the Lord Shiva took this halahal, and to subsidize this halahal, he took this ganja, this marijuana. So after long research, so in USA, they have developed a molecule. This is called anandamide, the bliss molecule, the molecule which can keep you happy. So if you see the word ananda, this ananda is a Sanskrit word. So ananda means happy. Mide is coming from this amide group, CONH. This is a amide group. So based on Sanskrit from Indian origin, this molecule was named as anandamide. Now, if we see the main origin of this ganja, bhang, this marijuana, it was originated from India. So now the Harvard Medical College is having so much research on this marijuana, whether this could be applied therapeutically to improve our quality of life. So that is why the scientific intervention is necessary. And for that, we need a chemist, we need biologist, we need botanist, we need pharmacologist. Lot of people collaborations are necessary. Now, if we again go back this Papaver somnifera, this poppy seeds, if some Bengali community people are there, so it is a very favorite dish to them. They call pusto, alu pusto, mas pusto, pusto bora. But for the first time in the world, this molecule, morphine, was first pure natural product was isolated from these poppy seeds. And in 1826, it was marketed by E-Mark. And interestingly, till date, if some patient is under very pain, like for cancer, so doctors still administer this morphine. So from 1826, this drug is still in use. But unfortunately, there is a other side. If someone is having little amount of acetic anhydride and any kind of base, you can convert this morphine to this dangerous molecule, the drug heroin. That is why nowadays this acetic anhydride is banned. You cannot buy acetic anhydride like any other chemicals in the laboratory because of primarily this. If you do the cultivation of poppy seeds, you will get the morphine. From this morphine, very easily within 2-3 hours, you can get a lot of heroin. Okay. Now, again, if we see the discovery of medicine, modern medicine from the plant origin, if you see that this two life-saving drug, this quinine anti-malarial drug, was discovered from the cinchona, and this anti-malarial drug, this artemisinin, was discovered for Artemisia annua. In 2015, the Professor Yu-Tu was given the Nobel Prize from the discovery of this artemisinin from the traditional use. It was a very interesting story. Student can read sometimes the discovery of artemisinin because it was almost failed. Then this lady again gone back to the traditional use. Then finally this drug came. And if you see again this Taxol, paclitaxel anti-cancer drug was discovered from this Texas baccata. And if you see this Catharanthus ruseus, two blockbuster drug, anti-cancer drug, vinblastine and vincristine, was isolated and characterized. Now is a running drug for treatment of cancer. This Catharanthus ruseus you can see everywhere. In Assam, you can find every household. Okay, now, but from this plant, now United States has earning billions of dollars from discovery of this. Now, again, if we see the discovery of metformin, now the metformin is the world best-selling first-line diabetic medication. If someone is diagnosed with the diabetes, the doctor first, he will give the metformin. Almost it is very known drug for entire world. But if you see the history of use of this plant, from where this molecule was obtained, in 1772, this plant was used for treatment of diabetes-like symptom. In 1940, this molecule was used as an influenza drug. But when this drug was given to the influenza patient, the doctor, this Johnston, observed that there was a lower of blood glucose. So then he started research on this molecule, whether this could be developed as a anti-diabetic drug. And finally, 1994, the US FDA has approved this drug for treatment of diabetes. And now this is the world's blockbuster drug for treatment of diabetes. So this is the group actually who finally brought this drug into the market. So now, if we come to the Indian context, the Indian system of medicine, we are raised with the Indian system of medicine, which include Ayurveda, Siddha, Unani, homeopathy, and yoga. But still, we are not gaining the same acceptance like modern allopathic medicine. So why we are not able to give recognition to our this Indian system of medicine? So now, if you see where is the gap? So now, if we see the gap after a lot of study, it was found that for this Ayurvedic medicine or Indian system of medicine, the quality is not assured, or toxicity is not adequately studied. When quality is not assured, why quality is not assured? So it is associated with a botanical quality of the botanical raw material and lack of information on the chemical composition. Again, the safety is not as standards in the regulatory affairs required by the healthcare industry. Also, sometimes we do not use for proper research methodology which has been used to develop the modern allopathic drug. So now if we see that what does it mean quality botanical raw material? So now if someone is working in a nasal product research and he need this Osbekia leaves, if I ask the village people and by chance he gives me the melastoma leaves, when these leaves are dry, they are almost look same. Even when not dry, these leaves are same. If you do not see the plant, you cannot differentiate the leaves. Suppose if I need Uzbekia leaves and someone gave me the melastoma leaf, so my entire research, entire generation of data will go to the waste. Or if I publish, I will publish a wrong information. Whatever I will claim, actually that was not in Uzbekia, that will be in the melastoma. So that is why the choosing of a proper plant with the help of a botanist or taxonomist is a very important to ensure the quality of botanical raw material. So next step is the active constituent. Now all we know, this turmeric is having the tremendous therapeutic potential. Why it is having the therapeutic potential? Primarily curcumin, then dimethoxycurcumin and bis-dimethoxycurcumin. Together this molecule will call curcuminoids. Now if someone asks to take that 10 or 5 gram of turmeric every day, so you will get the good benefit. Now if someone take this 5 gram from Lakadang variety of developed in Meghalaya, if someone is taking 5 gram from turmeric from Jorhat, and if someone is taking 5 gram turmeric powder from the Manipur, so the percentage of the curcumin content will be different. So when percentage of the curcumin, the active constituent will be different, the therapeutic effect will be different. So that is why when we prescribe that, okay, you take this much of turmeric, so it does not mean that in every places produced turmeric is having the same amount of curcumin. Instead of giving that prescription, if we developed a product where curcumin percentage is same, then it will give the same therapeutic value. So that is why in an Indian system of medicine, the evaluation of the percentage of active constituent is very important, in which we are still lacking. Then if you come to the proper research methodology, now if you see green tea, so why green tea is having therapeutic potential? Primarily because of this molecule. It is called EGCG, epigallocatinin gallate. Also green tea contains GCG, gallocatinin gallate, where both the molecular weight is same. So if we use LCMS, mass spectrometry, to quantify this active constituent, then it will be the not proper methodology, because this GCG also will contribute to the percentage. That is why we have to choose the proper research methodology. Even if you see that this publication from the same plant, they have reported different type of molecules having the same molecular weight. So that is why when some people do the research in nasal product, they take an extract, and by doing LCMS, they claim some molecule, but that is not exactly the correct modern method, because same molecule, same plant extract may have different molecule having the same molecular weight. So that is why it is very important to choose the proper research methodology. Now I am showing here our own experiment. So we worked on a plant, we collected 2 different seasons, we named as a batch 1 and batch 2. If you see the SPLC profile, the batch 1 and batch 2, same method, same concentration we have used, but there is a tremendous difference. If you can see very distinct difference between these 2 SPLC, and same is repeated in in thin layer chromatography also. If you see, this is visible eye, this is UV, this is batch 1, this is batch 2, and same in all cases. So that is why it is very important to standardize the plant extract which we get the activity, and every time we collect it, we have to check its SPLC profile and TLC profile. Now come to the toxicity. It is, we believe that natural products means safe. It is not true at all. If you know this Aconitum ferox, which is primarily available in Arunachal Pradesh, earlier people use this plant to kill animals during hunting. They put this extract into the front side of the arrow and then they kill the animal. So later, by doing research, people developed that this molecule is extremely toxic. Same, the one drug used in Ayurveda, this Ecorus calamus, they contain a molecule called beta-arazonon, which is a toxic, which is a precarcinogenic. So it is already proved. So that is why there's a lot of anomalies. Now, how we can then develop the modern medicine based on the natural products? So that this phytopharmaceuticals, new classes of drug has been introduced in India now. So now if you see, there are two words. One is phytopharmaceutical and another is botanical. This botanical drug or phytopharmaceutical drugs are almost same. In USA, they call it botanicals and their regulatory authority is US FDA, and source is plant, algae, fungi or their combination. But in India, we call it phytopharmaceuticals, and our regulatory authority will be DCGI, Drug Controller General of India, and it will be a plant source. It will be not single molecule, it will be a fraction, but it will be an allopathic drug. So now if we see botanical drug, USA has already developed 2 botanical drug and they are in the market. The Foliquezat is already they are marketing in 140 countries, which is used in HIV. So this is not single molecule. This is an extract, but this is an allopathic drug, and USA it is called botanical drug and it is regulated by US FDA. Now in India, 2015, the government of India has published this gazette notification that India is also going to have a new classes of drug which will termed as a phytopharmaceutical drug, and the regulatory authority will be Drug Controller General of India. So what is this phytopharmaceutical drug? This phytopharmaceutical drug will be a purified and standardized fraction from a medicinal plant with minimum 4 bioactive or phytochemical compound, which will be qualitatively and quantitatively assessed, but does not include administration by the parenteral route. That means this can be only oral drug. You cannot give the injection. So now India is going to develop this phytopharmaceutical drug, which is not a single molecule. This will be a fraction from an extract, but minimum 4 molecule will characterize, but this will be an allopathic drug. This will be not an Ayurvedic or Indian system of medicine. So now this is, student can give the attention. This is the strategy, what we follow. So I am a purely natural product based medicinal chemist. So this is the purely for the chemistry student. So how we isolate and characterize molecule. First of selection of therapeutic target. So anyone who wants to start research in the area of medicinal chemistry, he must have to have a therapeutic target. Like someone do work in cancer, someone works in Alzheimer's, someone works in diabetes, like someone may work in arthritis. So I have chosen to work in type 2 diabetes in each complication, especially in the diabetic nephropathy. So second step is selection of plant. How I can select a plant? So we follow 3 strategies. First, direct survey. Sometimes we go to some villages and then we meet some traditional healers and do survey. Based on that, we select the plant. Then Indian system of medicine. We search from the Ayurvedic book, Siddha book, Unani book. Then we can select this medicinal plant. So then we go for folklore. So particular community. So use some community medicine. But based on that also we select this medicinal plant. The next step is very important. So then during collection, you must have to have your friend or collaborator who is from the botany background, or he is a plant taxonomist. So after collection of the plant, we have to prepare the herbarium, and this should be submitted either some competent university, or especially in Northeast, I take help of Botanical Survey of India, BSI Shillong or BSI Arunachal Pradesh. So they used to authenticate our plant. After authentication of the plant, we go for extraction. So we prepare different kind of extract. We prepare methanol extract, we prepare ethanol extract, we prepare methanol water mixer extract, we prepare ethanol water mixer extract, and water extract. And all this extract, we evaluate the biological activity. The best extract, suppose my methanol extract is giving me the highest biological activity, then from this methanol extract, I do fractionation. So why fractionation is necessary? So the fractionation is just like a, suppose BSc Department of Chemistry, suppose BSc first year, second year, third year students are together. So if we want to separate all first year batch, second year batch, third year batch, we can follow different method, so we can separate. Similarly, we follow here with the increasing polarity of the solvent from N-hexane to water. Depend on the polarity of the compound, so compound will be fractionated into different solvent. So now here we used to get three different solvent fraction. The N-hexane fraction is very non-polar fraction, and water fraction is very polar solvent. Then all these four fraction, again we evaluate the biological activity. Suppose my butanol fraction is the best active fraction. From this fraction, then I do extensive thin layer chromatography, SPLC, then LCMS. From this, I isolate the pure molecule, then characterize with the help of NMR, IR, UV, and LCMS. Then we go for formulation or patent or publication. This is the basic strategy how we do the chemistry. Now, to do this chemistry, the student must be very much well acquainted with the chromatography. So generally the chromatography, what we used in the laboratory is a thin layer chromatography. Now, if you see the TLC1 in extreme right, there is a mixture of the compound. Then if you see gradually towards the left, the compounds are having separated. Again, the TLC2, if you see extreme left is the mixture, but right side you can see the top two pure compounds. So to do a TLC, so you need to have some silica plate, or you can make this silica plate by yourself. You need some capillary, you need TLC chamber, you need TLC solvent, you need some developing chamber, then visualizing chamber. So this is the, when we do TLC, first, always in TLC, we have two phases. One is stationary phase, one is mobile phase. The stationary phase may be polar, or stationary phase may be non-polar. Then solvent we use generally from non-polar, medium polar, then high polar solvent. Okay. So basis on the polarity, the compound used to get separated. Then we have to calculate. We have to calculate their RF value. So what is RF value? The compound distance from the origin divided by the solvent front from the origin. The RF value, as solvent front is always having the more higher value. So RF value is always less than 1, or maximum RF value could be 1. Remember, whenever you will appear some interview, this kind of critical question you will be asked. So the RF value could be maximum 1, or generally it is always less than 1. So these are the some TLC plate looks like. So what we used in our research. So these are the TLC plate. If you see, first TLC plate was visualized in UV chamber, then iodine chamber, then sulfuric acid spray. So these are the few solvent system. So for very polar compound, we use like a ethyl acetate, methanol, water. Sometimes acetic acid also we used as a solvent system. For medium polar compound like DCM, methanol, DCM means dichloromethane, then methanol, then N has an ethyl acetate. Also for visualizing, we used different spraying reagents like sulfuric acid, N-acetaldehyde sulfuric acid, vanillin sulfuric acid, dragon dove, ninhydrin. So also we have this SPTLC, which is very useful system. Madam, how many minutes I have?
10 minutes.
Another 10 minutes?
Yes.
Okay. So this is the SPTLC. All these facilities are available in our institute. And sometimes this is a preparative TLC. Suppose we used to do these things, then you can cut a particular band. Then we can check is LCMS, SPLC, NMR. This way also we can isolate and characterize molecule. Also we do column chromatography. So column chromatography, again, it's like a similar stationary phase. We use silica. So it is a polar phase. Then we use different solvent system. So here if we see in the top red, all compound mixtures are together. So slowly when moving, they will be separated and finally we'll get its individual compounds. From here, first less polar compound will be eluted and last the more polar compound will be eluted. First polar compound will be eluted, first the non-polar compound will be eluted and the last polar compound will be eluted, which is reversed in the HPLC when we use reverse phase chromatography. Suppose some compounds are very polar, we cannot elute with normal silica gel. In that case, we have to use reverse phase chromatography where the stationary phase will be non-polar. Here, the silica gel is polar. In column chromatography or thin layer chromatography, stationary phase we use silica gel, which is a polar stationary phase. But in reverse phase chromatography, especially in SPLC, so in SPLC, so this will be the polar. These are few compounds how we isolated in our laboratory. So then we check TLC. Now there is another TLC system. This is Dion SP2. This is a resin. Suppose we have an extract or fraction which is only water soluble. So only water soluble compound cannot be separated in a silica gel because we cannot use water as a solvent in silica gel. In that case, we use Dion SP20. This is a resin specially used to separate very high polar compound. Then also we can use this flash chromatography. This facility also available in our institute. Then the most important facility for a infrastructure for a natural product chemist is this machine. This is called high performance liquid chromatography. So here it's a reverse from this thin layer chromatography or column chromatography. In thin layer chromatography or column chromatography, non-polar compound eluted first because stationary phase was polar. But here we use non-polar stationary phase. So non-polar compound will elute later. First polar compound will be eluted. So these are like a few SPLC spectra. If you see the first methanol extract, then when we do the fractionation, EA means ethyl acetate. Ethyl acetate is less polar. So only the high retention time compound will be eluted. Then butanol fraction and then water fraction, the polar compounds will be eluted. This is the way how we can separate the compounds and we confirm from the HPLC. So these are different techniques like in SPLC, there will be a normal phase and mobile phase. Generally, you use methanol, acetonitrile and THF. So there are different types of column and sometimes we use acid in a SPLC. This is one of the very important equipment for a natural product chemist because when we isolate the molecules, we do not know the structure. To characterize these molecules, you must have to have very good knowledge in NMR, or minimum you have to need to do all these NMR, like you need proton NMR, you need 13C NMR, you need DEPT 90 and 135, which will give you the information on the carbon, whether it will be CH, CH2, and CH3. Then you need proton-proton cozy, which will give you the information on proton. Then HSQC, which will give information on the proton, which is attached with which carbon. Then HMBC, which will give you 2 and 3 bond proton carbon information. Then NOSI to find out the stereochemistry. So now in our group, we are working like a medicinal chemistry. So I am working in diabetes. So with a 3 different therapeutic target, I am working like this muscle cells we are working. So when we take food, the blood glucose increases in the glucose increases in the blood. So then what happens? When more glucose are in the blood, the insulin secretes, the pancreas secretes insulin, and insulin give the signal to the cell. Okay, there are a lot of glucose in the blood, go and take it. If there is a insulin resistance, then cell will do not take this signal and glucose will be in the blood. Cell will not take glucose. So we are checking this by using nasal product. Can we enhance the insulin sensitization and we can control the diabetes? Second, liver. Even if you diabetic people, when they do fasting, still glucose level is higher. Why it is happening? Because liver can store glucose, and liver can produce glucose without any carbohydrate substrate, which is called gluconeogenesis. But from non-carbohydrate substrate, liver can produce extra glucose, which is known as gluconeogenesis. So that is why even fasting state, many people cannot control the blood glucose because of the over glucose production in the liver. We are also trying to see whether some plant extract or molecule can control this gluconeogenesis. Also, we are studying in kidney. In kidney, there is a protein called SGLT2, sodium glucose cotransporter 2, which 90% reabsorption of the glucose occurs. So if we can inhibit this protein, so then glucose will be released through the urine. It will again not go to the blood, because this protein responsible for 90% of reabsorption of the glucose. On both this therapeutic target in our group, I am working. So this is one product like insulin. When it is function normally, it activates this pathway. Then finally this GLUT4 is a transporter which is located in the cytosol. It goes to the plasma membrane and bring the glucose inside the cell. But due to some free fatty acid, why we should not take much oil, why we should not take much junk food? Because this contain free fatty acids, trans fat. So which actually perturb this pathway, and finally the glucose cannot come inside to the cell because of insulin resistance. This GLUT4 cannot go to the cell membrane. It is similar like if I want to meet the vice chancellor of the this NEHU or principal of St. Anthony College, I just cannot go and open the door and go to his room. I need someone who will go and tell the principal, sir, that this person is coming. Can he come in? The GLUT4 is same work. So this glucose cannot enter into the blood, cannot enter into the cell from the plasma membrane. This GLUT4 will go to the plasma membrane and bring the glucose inside. So due to some free fatty acid, due to when we eat some junk food, this pathway blocked. So we are trying to develop some nasal product to sensitize this insulin blocking pathway. Also, we are trying to see how we can control the excessive gluconeogenesis in the liver. All this biological pathway, all infrastructures available in our group. Also, this is the SGLT2, very brand new therapeutic target. So we are working on it. So just one work I want to show. This is a Pramana Herbesia. So this is traditionally used for diabetes and many things. This is used in our Ayurveda. So we have isolated 2 molecules from this extract. One molecule from NMR, IR, UV, we characterized as a verbescoside, and another is isoverbescoside. Then we did all biological assay. This is called Western blot. So we just see the protein expression here, how this AMPK is working, how this AKT is working. So if biology students are there, so they will understand. So after seeing all these things in different cell and different proteins, so we have published this very recently in September 2021 in a Phytomedicine. It's a very good journal, 5.4 impact factor. So with this, I will stop here. So I'm very much thankful to my director and for giving me doing the work and funding agency. This is my research group at ISST. So last, I'm very much thankful to the all fraternity of the St. Anthony College, the organizing committee, Madam Diamai, also the Dr. Momo from CSIR Triple M Jammu, all you that giving me this opportunity to interact with you. Thank you, ma'am. These are the famous natural product chemists who started natural product chemistry in India, and Professor Sukhdev is still alive. Thank you very much.
Thank you, sir. You have completed within scheduled time given to you. So we are so grateful to have you, sir. We have chosen the right person for the right topic. Somehow the time given to you is very less. I hope we can invite you again some other webinar with more information. But in a short span of time, you have enlightened us so much regarding the natural product. So I think we have some questions. So do you have time to answer?
Yeah, sure. So I will try.
Okay.
So I may not be able to answer, but I will try.
Okay. They have given in the chat box, does this again follow the same and earliest ancestors as before? Does natural product an important approach like in the discovery of drugs?
Does this again follow the same and earliest ancestors before?
Does natural product an important approaches like in the discovery of drugs?
Yes. Because if you are a chemistry student, if you see one era, this combinatorial chemistry. So after spending 30 years in combinatorial chemistry, we have only one drug. If you go, there's some literature, if you contact me, I can give you. But if you see the discovery, the original discovery was always helping from the natural product. Why? In a plant extract, in a plant, you can have diversified molecules. It contained alkaloids, it contained terpenoids, it contained covariant type of compounds, flavonoids, all different types of molecules are there together. So if you have proper biological assay, only right molecule will choose the protein to bind it so that you can go ahead. For discovery step, still that is why if you see, this 2015 is very recent. Why then Government of India has again imposed as phytopharmaceutical? This is purely natural product based drug. And then why developed country like United States of America is now focusing in botanical drug, which is an extract, because there is a potential. I must say always natural product is helping in discovery step of the drug.
Some more question is coming, sir. Kindly suggest method for isomer separation from natural source.
So isomer generally, this if it is an isomer, you have to have some chiral column. In SPLC, there will be specific chiral column. It is very costly, so you can separate. We use chiral column to separate isomers.
Okay. Someone is asking a general knowledge. How does the apple help us to have a good health? What is there in apple that help us?
That is why I was yeah, I was showing, because we need more research. We know that always it is proverb is there, an apple keeps the doctor away. But we have to prove it. So maybe whether it is helping in nutrition, it is having some immunity booster. Definitely some compounds are already isolated and characterized from the apple. A lot of work has been done, but still apple cannot consider as a drug, right? So it is a food only. That is why I showed it, because we have some belief that we need to now prove scientifically.
So we need more of research to be done, more natural
yes,
product
yes.
research.
Yes.
So I have one question regarding
Yeah.
this diabetes. No, you are working with
Yeah.
that. So like, is there any plans that you have studied that will help control this sugar and all?
Yes,
Natural
yes, yes.
products?
Yes, yes.
Okay.
Yes. If you see
Because
recently we have published almost 3 or 4 papers, but these are traditional use plan. Okay.
yes, yes. Hmm.
But you see, these are showing we have, as I showed, we have 3 different strategy to see. Some plants work in liver, like metformin.
Hmm.
Metformin work in liver, so it control actually over hepatic glucose production. So then, like SGLT2 inhibitors, they do not work in liver, so they will inhibit the reabsorption of the glucose in the kidney. That is how. Still, we are working. We are just publishing the data, so we just cannot say that this could be a drug.
Yes.
So also we are working one plan. Dr. Momo is also working actually towards the development of phytopharmaceutical. That was original my work in IBSD. So now actually IIIM Jammu, then DBT and Imami Limited is also involving. So things are going on without having the collaboration with industry. It is very difficult to develop drug actually from academia.
Okay, sir. Okay, very good information we're getting from sir. I hope the students are benefited a lot, and I wish they will opt for natural products in after they finish.
Yeah, madam. Actually, we sometimes time to time advertise if some students really interested for summer training.
Oh, okay.
Like we have all machines like SPLC, SPTLC, LCMS, cell culture facility. So they can come in a proper way. Actually, they have to apply.
Okay.
Then if selected, so they can. We have student hostel also for summer training. Sometimes they may come to get a little bit taste of natural product or like that.
Okay, very interesting. So then we will keep in touch with you to send a student for training, and I hope the student also will be interested to join.
Yeah.
So should we go for more question, or you have to leave?
Yeah. So Dr. Momo. Hello.
So some of I think sir, some of the question we will send to you through email, and we will reply to them.
Yeah, they can interact with me over telephone also anytime.
Yes, yes, yes. Because you have to go for.
Yeah, Dr. Momo, can you hear me? I cannot hear you.
Momo, I think you have to unmute.
You hear me now?
Hello.
Hello.
Oh, yeah, yeah.
Okay.
Can you
I'm
hear me?
very sorry. Actually, Dr. T. Ramaswamy is visiting us along with some scientists from the DST.
Yes, yes.
That is why it is very unfortunate. So I'll not be able to your talk. Okay.
No, sir, your talk was very interesting. I think maybe some of the students who are in undergraduate and some of them, some PhD students are also there. They'll be really very much encouraged and excited about, more information they would like to know. The traditional knowledge that you have shared, maybe they will get into it and they'll come back to you.
Sure.
You have to
I'll be happy.
the students from there.
Yeah. Okay, so madam, so I will take a leave. I'm really sorry.
Okay, sir. We will meet again. We will invite you again.
Sure.
Thank you, sir.
So thank you.
Okay, sir.
Okay.
So, dear participants, some of you are sending some more questions. So, your question will be recorded. We will send to the resource person, and he will reply it through email. So, any other participant who want to send a question, you can send in the chat box. We will record your question, and then we will send to the respective resource person, and we can get the information through them. So, we will go to the next session. I'm very happy to have my friend here, Dr. Jasha Momo. He is my good friend, and through him, I have been able to invite JC Bora also. So before we start with the next session, I would like to give a little bit of introduction to our next resource person. So Dr. J.S. Momo Munshel presently is working as a scientist at CSIR Indian Institute of Integrative Medicine at Jammu in the field of natural products and medicinal chemistry. Dr. Momo have been associated with Northeastern Hill University, Nihu, Shillong for quite a very long time, and I have known him throughout as a MSc student, a research scholar, and as a former senior technical assistant at Safe Nihu for I think for very long years, maybe 90 years,
Yeah,
counting, right? 9 years.
almost 9 years.
Yes.
Yeah.
So his area of expertise are in the field of natural product isolation techniques, organic synthesis, and many more. If you want to see his profile, he has a keen interest in networking science with society, and therefore he is a life member of various association and chemical society like the RSC, the ACS, and many more. He has also been awarded the Young Scientist International Travel Scheme and few other travel grants to travel around the world to attend various international conference. And I know him; he has been traveling to Paris recently. So at present, he has three scholars working with him as PhD scholars and project associate respectively. So now I hand over the time to Dr. Momo so that we can get the best information from him. So Momo, you can take your time now.
Thank you, Dr. Sridhar. The first thing first. So I'm very happy to be a part of this national webinar. I would like to thank the principal of St. Anthony's College, Reverend Brother Dr. Albert Dakar, for this allowing this to happen, and also Reverend Father Joby Joseph was here, the director of the college, and the head of the department, Dr. I.C. Dalin Snatang. I think, if I remember correctly, she was our senior in the Department of Chemistry, NEHU.
Yes.
And when I check the profile of the department, I think most of them I am familiar with the faces. Even Fernando is also there. Dr. Mithunda is also there, and Baskem, Isidora. So many of you are there, except one person. I think he is a little bit junior to all of you. I think others I know all of you.
Yeah.
So we are familiar to one another. So thank you so much. It was a very interesting presentation of Dr. J.C. Barat. We are working on one DBT project together. That is where he mentioned about one medicinal plant from Northeast, Ficus semicordata. So I have seen the audience will compose more of an undergraduate and some from colleges, and also many. Mostly that is what Dr. Sridhar told me. So I have just briefly, in some generalized way, I have just prepared my slide. So I will just upload it. And so there is my slide visible now.
Yes.
I'm putting in a presentation mode. I don't know whether it has come or not. Okay.
Okay, it's coming now. Yeah.
Yes. What happened is, so if you want to be a scientist, you have to withstand failure. So this is said by Ben Parenga, the Nobel Prize winner in chemistry in 2016. So as Sridhar was saying, I met this Nobel laureate when I was in Paris, actually. So he was quite humble. He interacted with almost all the students, all the chemists who were trying to interact with him. At the same time, he was in the panel discussion for this climate change affecting all the global scenario that was happening. So when I look back into his background, he belonged to a family of 10 siblings. So 10 siblings in a family is not an easy one. So when he said, if you want to be a scientist, you have to withstand failure, maybe because of all so many other things, he may have said this. So it was so meaningful to me. So I just wanted to share this at the first go. So his work is beautiful. He got Nobel Prize in a way that if we can use molecule as molecular machines, organic compounds as molecular machine. This is a very interesting topic that he has done with 3 other Nobel laureates who have been awarded in 2016. So we will not go into that, but we will talk about natural products and its importance. So I will continue to share about nature products from where these molecules came. You see, if we talk about Taxol, we will find some kind of this Taxol species where they have isolated this anti-cancer drug in Megalia also, this Taxol. I think when I was there in chemistry department, if I remember correctly, even Professor Merbo and Professor Don Sim and other researchers were also involved with some of these species of plant. So this molecule Taxol is quite important. So this molecule is a bloodbuster. What according to we have just seen in the another presentation. So even we will not just talk about Taxol because nature has not just given us this molecule. We are given a lot of molecule. I'm highlighting just few. Even the next one, chemtothexin, isolated from the bar and the stem of this from this plant, Chemtotheca ecumenictar, and phyllotoxin, extracted from all this phylum species. And you have another one which calciaminisin gamma 1, isolated originally in mid-1980s from a chalky swell or caliche pitch. This is from swell. This is basically from this. This work is actually very unique. It is very interesting. From an explored area, this particular molecule was isolated. Often we have talked about it, what it can do and what it cannot do, and what is the status. So nature has given us a lot good molecules, a lot good drugs that we are aware. Some of them we are aware, some of them we are not very much aware. So in the next slide, we will go into Artemisinin. If you see the left hand side of the slide, you will see this particular plant, and this particular plant is available all in all the parts of Northeast. So, and not just Northeast, in Shillong, you will see this plant available. If you go to Nehu, you will see this plant, growing wildly, abundantly. But now this is in a cultivated format. So from this particular plant, what happened is, I'll just use a pointer. From this particular plant, they got this molecule Artemisinin. From the Chinese traditional knowledge, particularly this woman, Du Zhozhou, who got Nobel Prize in 2015 for her work. You see, if you go into the history of her, you will see so many things happening with this plant, with the traditional knowledge that is happening. So once they isolate this particular compound and classify what type of molecule it belongs, then they begin to start talking about how this particular molecule can be modified, how this particular analogs can be created. All these things, this particular scientists and beyond this particular Nobel laureate, there are so many scientists who have been working with this Artemisinin for now. But what I'm trying to say is, this type of molecules from plants or from wherever it is, are available in our region, in Northeast, and also especially in Meghalaya. See, the other one, penicillin. So if we talk about penicillin, what happened here? If you see from this, if you see this type of picture, you will not see that from here, from this, what type of this slide, or what type of this pattern, how this particular compound is isolated. So these are the three people who were involved in isolation, giving the structure of this penicillin and making use of this particular molecule or this particular drug in their times. And they were awarded Nobel Prize in 1945 in physiology and medicine. So what was the Nobel laureate statement? They said, for the discovery of penicillin and its curative in various infectious diseases in 1945. So it is a long way. You and I, if we go back, this molecule is much older to us. So natural product chemistry, what it is, from where this type of molecules we can get. So we can get it from plants, from marine, from microbes, and other sources like insects. And what we do a lot of extraction, isolation. We identify the heat identification. Then we try to do lead optimization, and so many things can be done nowadays. Mutational synthesis and precursor directed synthesis, semi-synthesis. Many of us are doing. I'm also trying to get into this, and some people are also doing diversity oriented synthesis. And later part, we go into this NCL if possible in this type of generation. Of course, this is a long process. I'm just giving you the perspective of how natural products are actually going and what is the flowchart in order to get ahead with natural product chemistry. So this is we will come back to the basic things that we would like to know: extraction and isolation of the secondary metabolites. We call it secondary metabolites sometimes, these natural products. So how we do, we particularly dry it, powder it. It could be in a mark form or it could be in some other way. Extract with a liquid solvent, you get a polar solvent, and also you get the not so polar solvent, the non-polar solvent, and also you will subject it to a column chromatography. You will use different type of this separating phase. You will isolate them, and then after isolation you will go into characterization, and also you will try to see the physical properties, the chemical properties, and after identifying that particular metabolite or molecule, you will go into some kind of semi-synthetic identification of those molecules and creating analogs and library. If this is what we usually traditionally natural product chemists will do. So I will talk about one plant which is named after this Khasi tribe, Simboco cassianus. So this particular, commonly people call it lemongrass. So this is very useful. This particular plant is very useful. See, here they have isolated this type of small molecules, which I use even in perfume, in tea, whatever the purpose, all these things, because of this type of molecule present, it is always used like this. Here in this field also, you will see one of the scientists, here the picture that is drawn here in Jammu. This name is from Simboco cassiana. Actually, the scientist from this Assam has done this long time back, and also still some work is ongoing and in parts of the region. So this type is always there. So now commercially people have grown, and not just chemistry wise, farmers are also getting economic benefit from this. So many of you who are in your undergraduates or somewhere else doing your research, you have to see something where you are looking for that is not just important in your area but also important to the society. So another one, if you go, hello, I see.
Hello, sir.
Oh yeah. Oh, okay.
Yeah.
Can you hear me or?
Yes, sir. Yes, we can hear you, sir.
So actually, what happened is here, if you go to Bada Bazaar, and maybe in COVID protocol, I don't know whether it is still open or not, you will see Soplang. So in Soplang, many thing has been already done, tissue culturing, and even here in some parts of the northern India, there is a cultivation. Just like even in Shillong, if you see, you will see some kind of cultivation there. So what kind of important molecules are there? Bioactive molecules are there. This type of biomolecules are there here. This particular work was done in the Department of Chemistry, Nehu, long time back. So in the 90s, they have done this. So the one who have done this one has shifted to Pondicherry University, and he has retired from Pondicherry University. So I'm continuing the work that maybe somewhere else he has left it, a chemistry part, but biologically many are doing right now. So the bamboo shoot, if you talk about this northeast, you will see a lot of bamboo shoot on the way to from Guwahati to Shillong. You will see a lot of bamboo shoots. So these type of molecules are present in bamboo shoot. So this is a particular. These are the molecules that is present in one of the species from China. So, but I'm still continue to isolate some of the compounds from this bamboo shoot. So some of them has been isolated, some are still in the process. So this is what it is. And maybe this is not very important, some of the work that I have done. And if we talk about, Sridhar was asking Dr. Bora about this one, any type of this, those who are suffering from diabetic, this particular plant is quite famous, Potentilla fulgens leniang, where if you go even to Bara Bazaar, you will find this picture. I click it from Bara Bazaar. So this one, my PhD one, you will find that in Bara Bazaar, and many are using it, but still the study is ongoing. But we see this type of molecules are there, which I have isolated. These are the phenolics. From here we see the pentacyclic compounds from the nonpolar solvent. So what we do, how could we get into that molecules, or what are the analytical and spectroscopic techniques we use for natural product chemistry? Here I will just outline it. Analytical techniques we will divide into the spectroscopic, this chromatographic, and this hyphenated. These are quite modern, but still we are using it. And this chromatographic, these are quite old, except few of them. These are very essential. These three are quite essential. TLC, HPTLC, HPLC, and GC. All these things are very important. After this, then we become a very important for spectroscopy, NMR, IR, UV, and mass spectrometer. These spectroscopy techniques are quite important, and also if we have the luxury of having this combined spectroscopy or chromatography, we get into the hyphenated or the temtem analytical techniques that we have. So NMR will look like this. So we have three NMR in triple IM. So this three, one is the 500 megahertz. Another one is the 400 megahertz, 200 megahertz that is available in our institute. So IR is simple. IR will just tell you the functional group region of the compound and also the fingerprinting of the compound. This is what we can do with IR. So chromatography, I will not go into this detail, but Dr. Bora has already talked a little bit about it. We have the stationary phase and also the mobile phase. In a stationary phase, what could it be? It could be silica, alumina, or even other metrics that we are using in this modern phase. So this particular scientist was involved in the discovery of this particular technique. So another interesting thing that I'm right now doing is I would like to go into the finding out some kind of this metabolites from the edible insects that is available in Northeast. Many have started in Northeast, especially I think Dr. Achilles Verma, who was asking one question, I think he also has done something on this particular one of the insects found in Assam. So this is what we can do. So why we will go to insects? This type of important molecules are found in insects. So when we go into this type of molecule, what it can be used? If you see it is antimicrobial. Somewhere else we also find that some molecule, this type of this diversity can have this biological active anti-tumor, and also it will affect all these cancer cells. These kind of things, it plays a role. So when you see all this kind of activities that is exhibited by this type of molecules, you are tempted always to find some kind of molecules from this sources. So chromatographic technique, this is the technique that we need to have in order to have to be a natural product chemist. You need to know about this, not just knowing the information, but you have to handle this so that at least you can be able to isolate some of the compounds or tell some of the things that is there in the TLC or in that chromatography. So here is the, I just took this reference from the left hand side from this particular journal. What happened is see, if you see the normal phase, if we go the normal phase, what happened? We will see this type, same compound. So if we go the reverse phase, reverse chromatography, you will see this type of compound in the reverse. Someone that is here, it is coming down. See, carotene. This is a simple thing. It can be done undergraduate. So this, I think, I encourage maybe the department can follow this type of procedure or protocol, and maybe we can design this in this format, and many undergraduate students can learn about it. So how we develop this TLC? We need to have a tank, just maybe a TLC plate, and just run it in the solvent, which will carry all the molecule based on their polarity, and it will separate it out. This is just the one slide of semi-gordata, this anti-diabetic plant that Dr. Ora was talking about. This is how we do it. Here, another TLC that I have just done is the extract of Vithania somnifera. This kind of extract, this particular plant is very important. It is also known as the Indian ginseng. So we see at least 1, 2, here, 3, 4 compounds. TL
Momo, we are not hearing you.
I think Sir muted himself.
Oh, okay.
Okay.
I don't know what happened. I will upload again my slide.
Okay. Yeah.
Can you see my slide?
Yes. Now we can see.
Oh, okay. Where it was? Where I was, Sridhar?
There.
Yeah, here.
Thin layer.
Yeah.
This
So
one, yes.
this is a high performance thin layer chromatography. So this are the thing that is available. You can see the whole spectrum from the extract to all the bioactive markers that is available in the particular plant. So this is how we do it. And also the column chromatography. If you see the column chromatography, see this was done in 1950s. Now we have a small column. Sometimes we need some big columns like this. If you visit my lab in Jammu, you will find 1 or 2 columns of like this. Sometimes we always need this type of column because sometimes we need some compounds in more quantity. This slide is just to demonstrate how the compounds are isolated in a column. And this small compound, this column here, after semi-purify, I purify back here again using some different type of size of the column. This picture was taken in 2011 in the same lab where I visited, and now where I have been appointed. This was I found it, so I was just putting it Few of my friends took this picture in 2011, so I just put it to show it. So the same thing, HPTLC, we have discussed, we have HPTLC in our lab. So these are the stationary phase when you talk about the normal phase. These are the stationary phase when you talk about the reverse phase. So in normal phase, what happened? These things will take place. Just the opposite of what happens in the normal phase. In reverse phase, the polar one will come first, and then in the normal phase, this type of this thing, again, the one that is polar will come at the last. So this is gas chromatography. Sometimes we cannot use all the other type of techniques. Then we use gas chromatography for this volatile compounds that we find. Aromatic plants are also available in Northeast, especially in the Himalaya Belt region. All this type of ranges of this plants, important plants, are available in our region. So we have to utilize this type of facilities and also maximize the outcome. So same thing. So this is a very simple technique. What we do, see the hyphenatic technique, GCMS, we also can do. After extracting the oil, you do it in GCMS, and we will be, and in this GCMS, we'll have a library of so many compounds where you can, it will match with the similarity of the compounds that is available. So these are the techniques that I have shown. I think, yeah, I have not taken too much time. This is the institute where I belong. The director is Dr. Srinivas Reddy. He is a fellow of the Indian Academy of Science, Bangalore, and also he has won J.C. Bose Fellowship this year. So he is the leader in this institute, and under his guidance, we are working very closely. So thank you so much. So this is it. Maybe I know I have not put so many things, but I have just in some way rushed it.
Okay, thank you, Momo. You have highlighted the various technique for the extraction of the natural products, and there is some question they are asking here. I think you can answer. Where does natural product synthesize? Like, can we synthesize from? Like, maybe you want to ask, can we synthesize in the lab?
Yeah. See, natural product can be synthesized in the lab. Taxol is no more extracted from the lab. People have done synthesis of Taxol, total synthesis, a very lengthy procedure, even morphine, whatever natural product that is there, you cannot always take from the plant. You have some kind of this ethical, because the amount of the plant that is required to extract the Taxol and to extract this bioactive compound are too much. So that one nature cannot give us again like this. We cannot keep destroying trees, or we cannot keep destroying plants again and again. So some other ways, usually natural product can be synthesized. I think maybe, yeah, we can synthesize from the chemicals that is available. People are doing it. Yeah, okay. It can be done.
So apart from nature, we can also synthesize by ourselves in the lab. Okay,
yes.
Okay. Then there's one more question. I think, okay, is acetonitrile used to extract natural product from medicinal plants? Can we use acetonitrile to extract?
No, basically we use it as a solvent, mobile phase in HPLC. HPLC, usually in HPLC. Okay. If you use it in extracting all these things, drying is a very difficult thing. You can use, no problem, but you see the smell of this acetonitrile, and also when you try to dry it, evaporate it, will be very difficult. Yeah, in a little amount we use, especially in HPLC, we use them.
Okay. So the there's a lot of work for the extraction and extracting of a drug through natural products. A lot of work in the lab. So students who are interested, you can opt for natural products. If you want to, I think Momo, you're giving some training also in your institute, right?
Yeah. Next year we will be. I mean, DST has approved. DST have approved. Maybe in the through your this webinar, I would like to invite students from all the. I mean, this is specifically for Northeast, and also from students from Ladakh, and also from some union territories. They can come, especially if they are MSc. If they are MSc, and also they are PhD students. They can come. You will be given. You will be given your traveling allowance. You will be given the for free fooding and also lodging. So you just have to come and learn the techniques of natural product and medicinal chemistry. So it is a very closely related discipline. So you can come and learn from many of the scientists. Very good scientists are there. I have just joined. I have just started. So many things for me. I'm also learning. I was in Nehu, so where there is a little bit of facility limitation and the resources. But now, in terms of this research, many things can be explored. But I also encourage maybe even St. Anthony College can have some center where traditional knowledge is documented. I would like to say yes. I don't know whether there's Reverend Father Joby Joseph is still there or not. Maybe they can think about it. The rector is still there or not. It is possible that can be also there because St. Anthony is a leader in that field. I mean, in education in Shillong. So people can always start.
Yes. So, Momo, do you have some more time for some question?
Yeah, I have time. I actually 12:30. The junior minister is visiting in by 12:30. So
Okay.
1 hour, but maybe I have no problem for me.
Yeah. Okay. So one more question is coming up. What makes a product natural in case of day-to-day life? Is penicillin still used now, or it's not actively used now?
See, penicillin resistance is there all the time. It is used as an antibiotic, but we have a lot of penicillins now. Maybe you will be aware if you go, people are not prescribing a lot, but sometimes people are taking. So, but many are synthesizing this molecule. There are analogs created, libraries are created for this particular compound. So many works are doing. Maybe some of them, the heterocycle chemistry, actually, where Professor Merbo and his students are working, they can do a lot of synthesis on this type of molecules. So maybe they have done also, who knows.
Okay, so okay, let me see. One more question is
one question, Sridhar.
from Safi.
This Sridhar last time that Dr. Achilles, that isolation, this chiral column, Dr. Achilles, maybe.
This one.
Well, his question, I have chiral column, so if we have some natural product, he can send me, Dr. Achilles.
Okay.
Here's it. It is good. I have chiral. I just bought it. I paid a few lakhs, and then I have it in my lab.
Okay. Which is less expensive, extraction of synthesized?
Yes. Which is
another question. Which is less expensive method for extraction of plants or synthesizing it in the lab?
No, depends. Depends on
no?
what molecule you are synthesizing. So when we do extraction, we will need a lot of plant. So
yes.
We will need a lot of plant one, and we will need a lot of solvent. And we will do so. We will require manpower. So when they do synthesis, supposing the precursor that they will use, if it is very costly, supposing it is costing more than 1 lakh, then we can get it from the plant and then extract it and give it to the particular scientist who will be, getting busy with the synthesis work. So sometimes it depends. Both are expensive. So which is more expensive, it is depends on what type of molecule you will be working on it.
So Momo
Is my
talking
question
about,
okay?
yes, any more questions? So I should I ask my colleague if they have any question to ask?
Yeah. Please.
Momo is still having time, maybe 5-10 minutes. He's still having time. So I'll ask some of my colleague if they have any question, or some student also if they have question they can ask. We still have time. And regarding the participant, please fill the feedback form given. Please write your name and institution correctly, because the name that you have given will be recorded in the certificate and it will be sent to you through email. So please write your name correctly and the name of the institution also correctly.
So where is Baskin, Dr. Baskin? He is there or not?
I think he could not connect, maybe because he is at his hometown. Maybe he's not getting that work. Yeah, he already informed me he's not getting that work.
Dr. Isidora Kakungar, I think
I think, yeah, I see you can show your face, Shampang. Maybe you can ask some question also. We still have time.
not the HOD, but the other one.
Isidora
The faculty member.
is working behind the scene.
Yeah. So Madeline is also there. Yes, I think. I mean, you.
Hello, Momo.
Yeah, I think we can really, because there is a lot of medicinal plant in Shillong. Maybe if the institute feels that we can document this traditional medicine and all this medicinal plant, and some of them still small facilities they can create, I think, if possible. Yeah, then it will be very helpful for the future students who are interested in this field. Though it is expensive sometimes, but still, if documenting may not be that expensive. So yeah, thank you so much for the invitation. Actually, Dr. Sudor, I don't know whether.
Thank you, Momo. The mechanism of action of penicillin. So maybe you can send through email to him.
Yeah. This mechanism, it is more of biology, and I may not be the right person answering well, but you can really work with it. This is the antibiotic. Long time. It was isolated in 1928. You see, and now we are talking about penicillin because it is very important. So students can also really think about it. How important is this molecule? Without this, even this COVID, the antiviral drug, some drugs are synthesized by some of the seniors here in my in this institute. One Dr. Divraj Mukherjee, Monoporovil, he has also synthesized one anti-COVID drug. I think he has published it, and maybe some company is trying to buy his patent, and then they will process. I have just joined, so I'm just beginning. And if students are getting interested, I have most welcome. Yeah. I think this Dr. Mithun, where he is, I don't know. It is good to see him. I see him here.
Hi, Momo. Dr. Momo, how are you?
Hello. I'm doing good.
Nice to see you after a long time.
Yes. Happy to see you also. Happy to see you.
I could not recognize you actually from your name, but now only after finding that you are the person.
Yeah. Okay.
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 Some question is there. Should I send to your email, Momo, or should you answer now?
What are some question where? What are the question? I am not able to see.
In YouTube, they have given YouTube. In the recent years, what natural product has been exploited to something useful beside medicine and pharma related? Means beside medicine and pharma related, what natural product has been exploited to something useful?
Something useful like cosmetic. They have gone in. You see something useful like perfumery in perfumes. So
Okay.
it is very useful. It is not just drugs, actually. I was talking. That's why I was talking about that lemongrass from Meghalaya.
Yeah.
That's why I was talking about some. Today I could not talk because it is the audience is more of this undergraduate. I'm told that's why I was not talking so much about the importance of this thing. I'm just highlighting few of the few of the important drugs. Otherwise, there are so many things nature product can do, perfumery, all whatever is available in our toothpaste. Daily we use toothpaste. They have added some kind of some volatile molecules, and then you see the sensation, the menthol that it is there. So all these things, it is used. Nature product is quite important actually. I am very happy that this college actually you have recognized the topic and you have converted into a national webinar. This is fantastic actually. We have to get to it, and we in the region has a lot of potential, and no, this is no one man's work. Actually, if we get into together, it will be a huge potential from the other parts. Advantage we'll have from the other region of the country also. Yeah.
Yeah. So much. So much to be learned. So I hope we can organize again this kind of webinar, like with more topics, more time. I think we need 2-3 days to talk about this. It is not ending. Like we're just getting the highlighting part of the natural product. So I think more in depth we will be able to organize again some days. So we will be calling you again, Momo and Sir JC Bora. It's very interesting. So very interesting. Yeah. So now I think I'll just inform again to the participant, please fill the feedback form, your name correctly and institution, so that it will be printed in your certificate. And for now, on behalf of the organizers, I would like to convey my gratitude to the management of the college for giving us the Zoom platform, then especially Sir Nathaniel, and then Father Joby for giving us a blessing through his prayer, and then the resource person, both the resource person, Dr. JC Bora, because in a short span of time we are contacting you, both of you, but both of you are ready to give the important information regarding this natural products. So in delivering us the best and giving us the best knowledge about natural product, and we hope to have more of this kind of webinar. So we need to learn more from you. The expert scientists, both are very experienced scientists and researchers. And I would like to thank the participant also, because without the participant, this webinar will not be as successful. And I'm thankful for your kind patience and for your question. And I hope to see you in the future webinar if you will be organizing later on. And also, I would like to thank my colleague, especially Philando, who has been doing all this technical work, especially sending email and then arranging everything regarding the Google form, and then this one. Now also in the we are having a lot of technical problem in the morning. He have done it very nicely. We have been able to start on time. Okay, we have some technical issue. So however, I'm very grateful to him, and also to everyone whom I'm not been able to say thanks. So I'm very grateful for your participation, and I hope to see you soon. So thank you all from the organizing committee. So I'm very grateful to you all. So I think now we can enter the program, and if you have anything to talk, we can talk now. Momo.
Okay.